Hi everybody, I am excited to be here. In the next minutes, I am going to talk about how revolutionary technologies such as Internet of Things, artificial intelligence, cybersecurity, and human augmentation can converge with chaos engineering. Nice to meet you. I am Yury Nino. I work as site reliability engineer in ADL Digital Labs, a company in Colombia. I am from Colombia. I am from Garagoa, Boyacá, in Colombia. And this company provides technology and innovation services. Also, I am chaos engineering advocate between Spanish community and my country. So, let me move. Probably many of you remember the transporter in the Star Trek universe. This machine was able to convert a person into energy. The machine could dematerialize the person from a target location and rematerialize her into another place. Here, a photo of Spock and Kirk transporting a person. Probably you remember it. This is how Eugene Weasley, the creator of the series, imagined the future 60 years ago. Although this is still an utopia. In other cases, such as Total Recall, movie predicted the rise of self-driving car, and it is today a reality with the Google self-driving car project, for example. Although these days we are living a critical outbreak, I feel lucky because I am living something that for William Hanna was a product of the imagination 60 years ago with Jetson series. We are living in the middle of a big black swan in which we are working remotely, we can a medical diagnostic using telemedicine, and we are exercising using videos. In the next minutes, I am going to talk about some novel research areas that have demonstrated a big potential in the solution of specific problems. I am speaking about Internet of Things, artificial intelligence, cybersecurity, and human augmentation that have shown a big progress in areas like medicine, teletransportation, software, education, and finance. For each one of these areas, I am going to explore how these emerging paradigms can use chaos engineering to manage the pains in the path toward providing a solution. So let's get started with Internet of Things. In the world we live, almost every single thing is connected in some way to the internet. The IoT is a pretty simple concept, taking all the things in the world and connecting them to the internet. Let me review a definition and some challenge that can be faced with chaos engineering. Internet of Things is defined as a network of physical and virtual objects with identities, attributes, personalities, and interfaces that are integrated in a transparent way. This definition was provided by Kevin Ashton, the co-founder of MIT Auto ID Center, who coined the term Internet of Things in 1999. In a shorter definition, says that the Internet Internet of Things is the interconnection via the Internet of computing devices embedded in every single object, enabling them to send and receive data. This sounds quite terrifying. If everything is connected to the Internet, anything could be hacked and messed with. One failure could ruin an entire day. A first challenge for IoT is related to resilience, a key aspect that has to be addressed if we want to recover devices, services, sensors, actuators, and obviously the networks involved in this technology. Nowadays, it is a common practice to use cloud computing to extend the scope and benefits of IoT. With these approaches, it is necessary to recover the network and its services in case of failures without human intervention. In this sense, novel architectures and patterns has been used with success, but we need chaos engineering to improve the resilience level of the infrastructure. With current IoT architectures, once a single device in a network is compromised, it can be used to disrupt the behavior of other devices on the same network. A single vulnerable device can undermine the security of internet network. Other solutions have used intelligence to train models that captures the normal behavior of each individual IoT device and used to detect anomalous behaviors. These solutions can be evaluated using chaos experiments that allow us to validate hypotheses about how they work. Taking into consideration that communication between applications and devices is vital for good performance of services in IoT, it is necessary to design architectures and mechanisms that provide reliability in communications, because reliability and availability in IoT is not only a matter of failure rate of things. We have to consider protocols, standardizations, logistics support, and other things, which impose a lot of challenge that can be addressed with chaos engineering. The convergence between people, processes, data, and objects is critical in Internet of Everything. I am going to share an open questions. What can we control? People, processes, data, or things? In my concept, we cannot control them, but we have a big challenge here. Ensure that all pieces are resilient, secure, and reliable. Chaos engineering is a perfect approach to overcome this challenge. Combining failures, hypotheses, and experiments, it is a good recipe for to face them. So now let me share some attacks that we can experiment in this field. Generate slow responses, for example, create cascade failures, intercept the integration points, and test the behavior of users. Users are very critical when we are talking about chaos engineering and we are talking about failures. Now the turn is for artificial intelligence. Nowadays, AI is a hot topic in many fields and contexts. One of the discussion points is about how reliable are the models used in artificial intelligence. To use AI in a worldwide way for humans, we have to create a trust and reliable relationship. In this sense, chaos engineering can be very useful to guarantee a proper level of reliability. How one define AI can vary greatly. This is a definition that I like. Artificial intelligence is intelligence demonstrated by machines. A more formal definition says that AI is the area of computer science that studies how machines can perform tasks that will normally require an agent, a sentient agent. The question here is that if we are going to trust in these machines for doing things such as driving a car, give instructions in an airport, for example, or share a beer like in this photo, we need to trust in them. They must be reliable. Here, the principle of chaos engineering have a big opportunity to be applied. So I have seen a lot of words and marketers saying that chaos engineering will soon be paired with artificial intelligence and machine learning tools to help automate a lot of the analysis and recover activities. They are designing smart systems that will be better at scanning networks and cloud environments to monitor performance and stability during tests. However, what about these systems? Are they reliable and resilient? Let me explore this in the next slides. We can start with big data, a form of AI. Nowadays, at a high level, organizations are tuning to big data and analytic solutions to navigate the challenge that they are facing. Organizations, for example, are using big data to manage customer experience, transform their products, and deliver digital services. Considering that those are many sides of the business, we need to ensure this data is reliable. And again, if we are talking about reliability and availability, with security, we have to talk about chaos engineering. Chaos engineering is perfect here. If we need reliability to apply in this field. So another big side of AI is related to machine learning. But what is learning? Let me clear there. Learning is the acquisition of knowledge or skills through study, experience, or being taught. These robust machine learning systems and hardware architectures are required to generate reliable and trustworthy results in the presence of hardware level faults while also preserving security and privacy. So since computers exist, people have tried to teach them how to process human language, but only recently, with the rise of new technologies and ever-increasing computer power, natural language processing has made its entry in our every life, whether it is a device processing human speech like Alexa, for example, or written language. And how are machines able to understand language and extract information from it? Computers are built to process structured numerical data, so an inconsistency and volatility of human language therefore turns natural language processing into a complex task susceptible to fail. What makes processing language a very complex task that needs a reliable technique to prove it. Chaos engineering is a perfect option here again. So in artificial intelligence, chaos engineering is very useful to test models injecting failures. I think it's a great opportunity to evolve our knowledge and progress for our unexplored field, chaos as functions. I would like to work on this in the future. And in the next slide, I would like to introduce how artificial intelligence could be used to classify postmortems. This is TOLP. TOLP is a platform that we are implementing in one chaos engineering guild that I lead in my work to investigate topics related with chaos engineering. Although at this moment we just have the designs and some POCs, but our goal is to have a system for classifying postmortems available in the web. With the objective is getting few and important information that could be used when we are facing a new outage. At this moment, in an incident or an emergency, we don't have time to process all information available on the web, on the internet. So with a trained model, with previous postmortems, we can input the information of our new incident and to get information that will provide the most value to resolve the emergency. So in this, in a third side, I want to talk about a cybersecurity challenge. In recent years, cybersecurity is a buzzword that we hear every other day. There is a drastic increase of the opportunities as well as the people interested in this field. But the problem that many of them face is that they don't have a complete picture of what is cybersecurity actually and how they could be the right fit. And in this sense, we don't have a clear protocol to test it. There is a great book that integrates security and reliability. Probably you know it. I am talking about building secure and reliable systems, best practice for designing, implementing, and maintaining systems from Google. I would like to recover these sentences from the book. Cyber attacks are more about manipulating vulnerabilities in human psychology than the adversary technological sophistication. And that is a reason for security and reliability topics, for example, SLAs related to this are often hidden in customer expectations. When we want to negotiate these topics, we prefer not to commit with the customers. Oh, that is my case. A third challenge here is related to virus evolution. Computer viruses are evolving. It is hard to recognize relevant patterns that have seen previously. But the theory behind chaos engineering could be useful here. And specifically, the progress the immune artificial systems. And artificial immune systems is an intelligent system that learns to recognize relevant patterns that have been seen previously. Using these techniques, the system are able to construct patterns detectors defend of similar attacks. And an artificial immune system is an intelligent system that recognizes and learns from failures injected previously, which is a principle in chaos engineering. So reliability is a core pillar of security testing, and offensive security testers will often try to exploit reliability failures to penetrate systems. Although penetration testing and chaos experiments share some parallels, they have different goals. I have to move quick because I lost time in the start. Sorry. As I mentioned, cybersecurity is about humans, so human factors are important here. Human factors in cybersecurity are perhaps the biggest challenge when building an effective threat prevention strategy. So humans operate differently when they expect things to fail. So that is a fact. And in this sense, chaos engineering has a lot to contribute to this field. With this context, I would like to share a new concept, security chaos engineering. It is the identification of security controls failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions in production. So that is the definition provided in the last chaos engineering book published in April in this year. So the adoption of the security chaos engineering principles across people remains as an open challenge. Security may be included in chaos maturity model, since combining a chaos maturity model and security chaos game days help new customers to start their chaos engineering efforts and allow to build resilience on security. So let me share some experiments with security and chaos engineering. For example, introduce latency on security controls, drop a folder like a script in production, simulate permissions, collisions in a shared role policy, and disable a multi-factor authenticator, for example. That would be wrong. Finally, I would like to talk about human augmentation. Human augmentation has been studying. Okay, my time. Okay. Human augmentation has been studied for many years. This field refers to the effective use of information technology in augmenting human capabilities, and the idea has been around since 50s. Let me talk a little more about this and share my thoughts about how it integrates chaos engineering here. So advanced human augmentations provides a human-centered perspective on technology design. So according to ResearchGate, advanced human augmentation provides a human-centered perspective on technology design. So it builds upon earlier technological concepts such as ubiquitous computing, wearable computing, augmented virtual and mixed realities, and autonomous systems and ambient intelligence. So before to introduce to challenge, I would like to distinguish automation from augmentation, which is defined as using science and technology to improve the performance as attacks. While human augmentation, that is the point here, is defined as using science and technology to improve them, to improve a human, sorry. Here, again, reliability is present. And if we have a challenge related to reliability with security, chaos engineering has a lot of highlights to contribute here. It is very important to keep in our minds that augments go beyond what user is capable of doing on their own. So let me move because I don't have more time. And a second challenge is related to safety. If someone will work closely and frequently with a device or potentially wear or implant it, safety is a super important concept here. So augments needs to be tested with rigorous safety standards in all phases. Chaos engineering will be very useful to cover these test requirements and obviously to guarantee that these systems are safe and reliable. So here we have some challenge that requires special considerations. Remember, we are providing solutions for humans to guarantee a better health and life quality. An error could mean one or many lives. So let me know, please, if you have more ideas about how integrate chaos engineering with these technologies that we are exploring as part the activities for investigation and development in my work. So let me know your ideas in my social network. Thank you very much for listening to this talk. My apologies for the beginning in this presentation. This is my personal webpage and my user in the social network if you want to contact me. Thank you very much.
We haven't had any questions on BigMarker yet, but I did love the way that you ended on, we were doing this for the humans. So when we're talking about folks getting started into chaos engineering and trying to get buy-in from their leadership, do you have any recommendations on how they can position it that way of like, we're doing this for humans, for our customers? Like, what is it that you feel is the best words of advice?
Yeah, okay, that is nice. That is a critical part in chaos engineering. Humans are very important here because humans are related to failures. And for example, when we are talking about security, human behavior is critical in this part. So my recommendation in this case, if you're starting with game days are a best way to interact with humans and to train about chaos engineering and promote these practices in a company. And they are spaces in which we have the opportunity to interact with another humans. That is great. So that is my first recommendation. And the idea of these spaces is to keep in our minds that is a safe space for humans. So that is.
That is so on brand and very good word of advice. The other question we have that is coming in right now: how do you confidently experiment on artificial intelligence and machine learning systems where you don't necessarily know what the expected output will generally be?
Okay, in this case, I have explored two sides. When we have when we are talking about architectures in artificial intelligence, and they need to be reliable and available. So it is very important to use chaos engineering here because the architectures running these models, this infrastructure requires to reliable and available. So that is very critical. Chaos engineering is critical here. But in the other side, we have a lot of things to learn about artificial intelligence in chaos engineering. Because, for example, with tool, we can use artificial intelligence to train models in order to classify postmortems. That is valuable for managing an incident in production. So in my concept, we have a lot of things to explore in this field. That is an introduction and some ideas to explore. But with security, we have to face a lot of challenge and to face a lot of restrictions with anything in this field, such as the questions propose.
Yeah, no, definitely. We definitely have a lot of learning to do, and I think that's one of the best parts with chaos engineering too, is that we are really just learning, and it's making our systems better through that. We do have more questions coming in, but we're up with time, so we're going to post these questions over in the QA channel. So if you want to keep on chatting with Yury and continue getting inspired by her thoughts around chaos engineering and artificial intelligence, machine learning, and security space, head on over to the channel QA Yury-Nino-Roa. Muchísimas gracias, Yury.
Gracias a ti, Ana. Gracias y es un honor para mí estar acá. Gracias. Bye. Have a good day.